Okay, welcome back again, ladies and gentlemen. This is Dr. Robinson, and we're going to continue talking about proportional relationships. So we're going to start off with our vocabulary. Proportions are two equal ratios. And remember, we talked last time about ratios of fractions, so we're talking about equal fractions. But now we're going to talk about the relationship of the equal fractions. So proportional relationships are relationships between two equal ratios. And remember, a ratio is a fraction. Our lesson outcomes, what we hope for the students to learn, is that they will understand that two quantities are proportional to each other when there exists a constant, which is a number, that such that each measure in the first quantity is multiplied by this constant gives the corresponding measure in the second quantity. Our second outcome we're hoping the students master is when students identify the measures in the first quantity with x and the measures of the second quantity with y, they will recognize that the second quantity is proportional to the first quantity. There's a formula we're going to talk about a little bit later in our next video. Y equals kx for some positive number k. They apply the same relationship when using variable choices other than x and y. So we want to use other letters besides x and y, so we don't want to just get wrapped up into those letters specifically. So let's take a look at our first example. During Jose's gym class today, students visited stations. Next to each station was a chart displaying how many calories would be burned. Is the number of calories proportional to time? How do you know? Well, there's Jose jumping ropes, so I assume he's at the jump rope station. And here we have time in minutes, which we'll call x. Y, it's our first quantity, and calories burned we'll call y, which is our second quantity. So that x would be our numerator and y would be our denominator. So time in minutes, notice it goes from 0 all the way to 4 minutes. Each one of these numerators up here corresponds to a y calorie value burned of 0, 11, 22, 33, and 44. Now I'm noticing something here. There seems to be a pattern. 1, 11, 2, 22, 3, 33, 4, 44. Well, I'm trying to figure out what's the relationship between these numbers. So there's something being multiplied by the x value to give us the y value. So if I multiply something times 1 to give me 11, what would that be? Well, it would be 11. 11 times 1 is 11. And now I'm looking to see if that's going to be constant or constantly appearing when I multiply 11 times the other values just to see if they come out to this y value or the calories burned. So 2 times 11 equals 22 calories burned. So if I spent 2 minutes and on the jumping rope, I would end up with 22 calories burned. So I notice that's being multiplied by 11. If I spent 3 minutes jumping rope and multiply that by 11, I would end up with 33 calories burned. And if I spent 4 minutes jumping rope, I noticed I would end up with 44 calories burned. So I noticed every time it got each minute was multiplied by 11 constantly. Well, what if I didn't jump rope? At any time, no minutes, 0 minutes. Well, if I didn't jump rope any minutes, I assume I wouldn't burn any calories. So 0 times 11 gives me 0. So this holds true when I multiply x value, which is the time, times 11. That'll give me the value of calories burned, which we called Y. So we can make the statement Y equals 11 times X, or 11X. So the value of the calories burned is equal to 11, which was the constant number, times the X number of minutes that we did the jump roping. So is this a relationship? Well, remember, relationship, being proportional relationship, has to be equal fractions. Well, 1 over 11, if I reduce that down to its simplest form, it'll be 1 over 11, so I can't reduce it anymore. But if I take 22 over 11, 2 over 22, and let me get my calculator out. 22 over 22. Hey, that reduces down to 1/11. What about 3 over 33? That reduces down to 1/11. And 4 over 44. That reduces down to 1/11. So, yeah, all of those fractions are the same. So they all have the same fractional value. 1 being the X value, first number, the numerator, and Y being the denominator, which was the calories burned, 11. So that is 1 over 11. So yes, it is a proportion. All these fractions are equal. So I know it is a relationship. The time is always multiplied by 11. So let's see. Here's one thing we could add to that. If Jose jumped rope for 6.5 minutes, how many calories would we expect him to burn? Well, we know. Here's our chart. 0 minutes, 0 calories burned. 1 minute, 11 calories burned. 2 minutes, 22 calories burned. So we're trying to get to 6.5 minutes. How would you expect him to get 6.5 minutes in worth of calorie burns? So how much calorie burning do you think he would do? What do you think? What should we do? Well, if you said multiply, that's right. Let's get our calculator out. So how many minutes did Jose jump rope for? 6.5. So 6.5 minutes. So let's type that in our calculator. And we're going to multiply that by 11, because each time that's the number that gave us the constant value that we multiplied by X by. And this will give us how many minutes? 71.5 calories he should burn in 6.5 minutes. So I expect him to burn 71.5 calories. So all I had to do was multiply by 11. So if you got 71.5 calories, you are correct. Nice job. So I hope you understand what we've done so far. If you don't, rewind the tape, take a look at it again, check and see if you have any questions, write them down. We'll be glad to talk about them tomorrow. We're going to visit other questions like this also. So take a look at what we're going to be facing tomorrow. Here's a nice long question about somebody working in the summer and how much money he's looking to buy a gaming system. So there's some charts that there's a chart at the bottom that you need to fill in for the values like we just did for Jose. So take a look at it, and tomorrow when you come in the class, hopefully you'll be able to tell us how do we know if two quantities are proportional to each other. How can we recognize a proportional relationship when looking at a table or a set of ratios? So hopefully you'll be able to answer those questions. So we've come to the end of our program. So this is Dr. Robinson. I hope you got something out of it. So I will see you at our next class. Take it easy. Bye-bye.